Physics Part 19. Well, the relation between the pressure is where theta h is the difference in vertical heights between the levels of liquid in two arms of the tube. P is the density of the liquid and g is the acceleration of free fall. To find the pressure of gas, all we need to do is to measure the difference theta h between the liquid levels and assume that P atm and G are known. In some laboratories, a U-tube mounted on board to which a vertical millimeter scale is attached may be available. This device is called a manometer. It is then a simple meter to measure theta h. If the manometer contains oil or water, the liquid in the tube will have a curved surface which is concave downwards as shown in the figure. The surface is called the meniscus. Use a set scale to find the reading on the vertical scale corresponding to the bottom of the meniscus to each side of the U-tube. The surface of the liquid in the manometer filled with the mercury will be convex. Figure 2.14, and in this case you should read to the top of the meniscus. Again, use a set scale to avoid parallax error. If a manometer, I beg your pardon please. If a manometer is not available, you will have to arrange your own system of U-tube and scale, for example, a half-meter rule. Make sure that the scale is clamped vertically. Method of measuring mass. The method of measuring mass with balance, in fact, balances compare the weight of the unknown mass with the weight of the standard mass. But because weight is proportional to mass, the equality between the unknown weight and the weight of the standard mass means and the unknown mass is equal to the standard mass. In your laboratory, you may have access to a number of different types of balance, including the top pan balance, the lever balance, and the spring balance. It is important that you should familiarize yourself with the use of all those balances, because you more learn them and you more get yourself familiarized with them, you get the accuracy of the performance. And this accuracy can only be achieved by the practice that you make with these equipments, the apparatus, and use of all types of that are available to you, so that you do not restrict your choice to one particular type. Note also that some type of spring balance may be calibrated in force units, that is in Newton, rather than in mass units of kilograms. The top pan balance, figure 2.5, is a direct reading instrument based on a pressure sensor or sometimes a spring. The unknown mass is placed on the pan and its weight applies for a force to the sensor. The mass corresponding to this force is displayed on a digital readout. When using the balance, ensure that the initial unloaded reading is 0. That is a control for adjusting the 0 reading. The balance may have a target facility for use in backing off the mass on an empty container to that the mass of material added to a container is obtained directly. It works in the same way as adjusting the balance of the 0 error. The uncertainty in the reading of a particular top pan balance is likely to be expressed as percentage uncertainty of the reading shown on the scale. together with uncertainty in the final figure of the display, the spring balance and the lever balance, the spring balance and the lever balance.